not very much brand specific, like, so everyone can understand, hopefully, whatever I'm going to say.
Yeah, very good, sir. So, sir, it's 2:35. We have 91 participants.
Yeah.
Shall we go ahead and start?
Yeah, sure.
Okay, okay. I just want to confirm, Sujay, sir, are you online?
Sure, sir. Yes, sir.
Okay, okay. So, sir, so let me go ahead and wish everyone good afternoon. I request all the participants, please keep your mics on mute and your audio also on mute. Okay, there is a lot of interference. So I request everyone to please, as I'm sure you have all attended the webinars, so please keep your mics on mute and your camera also off. So good afternoon, everyone, and welcome to the webinar, Transport Sector Fuel Efficiency, Behavioral and Technological. We have with us Engineer Suresh Kumar, sir. I now hand over the platform to Sujay K, Assistant Professor, Automobile Department, who will welcome our esteemed guest. Sujay, sir.
Thank you, Krishi, sir. Hope I'm audible, right?
Yes.
Yes, sir.
Okay. Good afternoon, all. It is my pleasure to introduce Engineer Suresh Kumar, sir. As today's speaker, Shri Suresh Kumar has completed his BTech from NIT Surathkal and has done PG from IIT Madras. He is working with Hindustan Petroleum Corporation Limited, HPCL, for the last 5 years. He is on deputation to Petroleum Conservation and Research Association as Additional Director in charge of Kerala and Lakshadweep. He is involved in perform, achieve, and trade audits of all major refineries of South India. In the transport sector, he has been associated with Ksrtc, oil companies, Kerala Police, and driving school for training on fuel efficient and driving techniques. So we have a very experienced resource person. I'm taking this opportunity to welcome you, sir. Engineer Suresh Kumar, sir. We are organizing this program in association with Society of Energy Engineers and Managers. Here we have Mr. Richu Sakriya, Joint Secretary Academics of SEAM Kerala. I'm taking this opportunity to welcome Mr. Richu Sakriya also. Welcome you, sir. Every program, every webinars will be a success of a very good strength of participants. Right now, we have nearly 100 participants with us in this program. Hope more will join soon. So very good participants will take this concept to next level. So I'm taking this opportunity to welcome each and every participant. So enjoy this session. Good afternoon, and welcome you all.
Okay, thank you, Sujay, sir. So before I hand over the platform to Suresh, sir, just a brief introduction about our college, because we have a lot of participants from outside our college unit. So the Department of Automobile Engineering is a part of SCMS School of Engineering and Technology. We are located in Kochi, and we are actually 37 kilometers from Kochi and 40 kilometers from the main highway that connects Kanyakumari to Kochi. And we are established in 2004. We have a BTech UG program with an intake of 60 students. And as of now, we have conducted a lot of programs related to because of Corona. We have conducted a lot of online programs, and one of our flagship program, which concluded recently, was the Auto Quest 2020. And we have also conducted road safety awareness programs online in various schools, where Mr. Sujay K, who just spoke, was the main resource person. We also conducted online webinars covering a lot of topics for our students. These were closed. This was a closed session for only SCMS students. We are also involved in various activities because the number one resource that a college has is our students, and because of our students we have earned a lot of accolades, and we have our students have participated in quizzes, in some national competitions also, where they have successfully won competitions. They have participated in major events like SA India Baha, and we have a very active go-kart program where we have participated in the go-kart series and in the IC engine go-kart series. We also conduct a lot of student enrichment programs through with the support of SA India Collegiate Club and SA India Southern Section and SA India. And we have because with their support we have invited a lot of resource persons to our campus. But now because of Corona, we are arranging a lot of online sessions. One of our Another flagship program of ours is Auto Workshop, which was a hands-on workshop where we shared our knowledge on automobiles with students from mechanical and other branches, where they would get a hands-on experience. And this is again another program which we are very proud of. We had an opportunity to work with Mahindra for a special program which they conducted for 5 days on our campus and in the surrounding areas. And this was an event. We have also been involved in a lot of social outreach programs with the help of, we supported CII's Young Indians initiative, and we also helped organize their own Not Okay Please social awareness program. We have also been contributed to alternate fuel research. Our Biofuel Institute has developed coconut fuel, a coconut oil based fuel, which we have done the technical side and we have tested it in a Tata Ace vehicle. We have also again been associated with Mahindra to conduct their Kerala region finals in for the Mahindra AQ season 7. So this is a brief idea of our institution. This is some of the programs that we conduct here. This is our Ignis, which has a Rapidus Auto Show, which is well known in Kerala. And this is our core laboratory where our students get a lot of practical experience. So thank you all for your patience. And as my colleague has said, we are conducting this program in association with SEAM, Society of Energy Engineers and Managers. And we are also working in association with PCRA, Petroleum Conservation Research Association. So one of their main jobs is to advise institutions and advise the government on how to reduce fuel consumption. Okay, so this is I am going to hand over the session now to our esteemed guest, Shri Suresh Kumar, who will give us a good idea about this. Thank you, and over to you, sir.
Koshi sir, 1 minute, sir. I think so participants, please mute your mic. Okay. Sorry for the disturbance, sir.
Yeah, thank you.
Sure.
Over to you, sir. Over to you, sir.
Hope I'm audible.
Yes, sir. You're audible, and the screen is also visible.
Okay. Thank you, Sujay and Koshi sir. A very good afternoon to all, and very nice to hear about the varied activities which you are under automobile department, be it tie-ups with OEMs, activities of numerous kind, then road safety, then including vehicle maintenance during lockdown. That also some caption I was seeing. Nice to know. Today, this afternoon of a holiday, I will try to present lots of informations. Many of them will be more general in nature, so that it's irrespective of your branch, everyone will be able to diagnose it and absorb it. And in 3-4 topics, I will take today's session. So at the end of each session, I will give you a 2 minutes break so that you can ask questions. So today, I am also having a very, like this is the first time I am making a presentation on transport, a group of automobile intern. I will also be able to carry home some information, tips from you. So with these few words, let me start. The topics covered primarily on the transport sector in energy consumption and CO2 footprint as regarding the on a national role, then factors affecting fuel efficiency, then CNG vehicles, electric vehicles, and battery technologies. And the last session will be principles of eco driving, that is kind of improving our own driving. As you know, Indian automobile industry, it primarily has 3 main clusters, you can say. In the south, Chennai, Oragadam, west, Pune, Ahmedabad, Aurangabad, and north, Delhi, Gurgaon belt. And automobile industry contributes 7.5% of national GDP and 49% of manufacturing GDP and employs 8 million people. And in the last quarter, Q1 GDP of India, you would have read in media, newspapers, it has contracted by close to 24%. And the contribution of the manufacturing sector was minus 40%. So needless to say, automobile itself would have contributed a majority of that 40% shrinkage. And so I'll be talking about fuel efficiency, carbon footprint reduction, etc. So this graph, as the color indicates, this shows how much of emissions the world is emitting. So China is the biggest contributor with 27.2%. United States 14.6%. Next is India. Then you can see even Japan 3.3, Russia 4.7. Europe, they are all small countries. Emissions are comparatively less. And why I am showing this graph here is one of the underlying principle which prompted the government, not only the national government but the whole world, to think in the lines of emission reduction, more efficient vehicles, public transport system, are all with an end point view of reduction of global emissions and sustainability aspects. Okay. Now, if you look at countries with most emissions, number 1 is China, which emits 10.0 gigatons of carbon dioxide, and per capita emission of 7.05 tons, followed by United States 5.41 per capita annual consumption of 16.56 carbon dioxide tons per annum. And third is India. The figure is, here it is 2.65 tons, 2.65 gigatons, and per capita emission is 1.96 tons per annum per individual. If you see the list on the right side, ours is the lowest because China 7, United States 16, Russia 11.74, Japan 9.13. One primary reason for lots of the developed countries is that lots of energy is being consumed for space heating or space cooling, or the air conditioning, you can say. In India, we have a majority of buildings with a vast majority of buildings with a naturally ventilated system. And whereas in all these countries which I have listed here, the space cooling occupies a significant portion of their energy consumption, and as a result, the per capita emission is also quite high. So as you know, Paris Agreement of 2015, wherein India decided, if you see the figures on the right side, targets by 2000 reduce greenhouse gas emissions per unit of GDP by 33 to 35%, at least 40% of electricity generation from non-fossil fuels, including carbon sink of about 2 billion tons. Additional targets which are not part of the agreement, like 100 GW solar installed capacity by 2022, 15 GW biogas installed. This 1 and 2, again, we are on track. So only biogas installed capacity, we are a bit lagging. And you see the projected carbon dioxide emissions intensity reduction from power sector. Power sector only I have shown here. So in 2005, our emission per GDP, emission intensity per GDP was about 155 grams. This figure is 0.155 is in kg. So it was, for sake of remembering, you can say it was 155. Then today we want to bring it to 15.5 to somewhere close to 9.2. Then further we want to bring it down to 7.2. And the reduction what we have already achieved over 2005, as on date it could be about 30-35%. By 2022 we want to achieve 40.5%. And by 2027 we want to bring it down up to 54%. One of my earlier slide, you had seen 100 GW capacity of solar, 100 GW capacity of wind. So today's, yes, I'm not saying, projected as of March 2022, 1.5 years from now. So we have coal-based power plants contributing to about 45% of installed power capacity. We will have gas-based power supply by about 5%. Hydro power projects about 11%. Nuclear about 2%. Renewables about 37%. This figure you just note on. It's not as though we say solar, wind and all. It's not a small contribution. So somewhere on the coal-based power plants, they are contributing more or less static, and it will fall down since the whole denominator is going up. This is the government's plan for creating or generating more efficient or less polluting power sector generation in the coming year. Continuing from the Paris Agreement, just note on, so two primary things what we have just talked about, two main things. One is that 33% reduction of per capita emission intensity from 2005 levels. So per capita emission per GDP, emission intensity you measure in two ways. One is from the power generating plants, how much carbon dioxide per kWh generation of electricity is being generated. That is carbon dioxide grams per kWh of power. That is one unit of measure. Second unit is emission, that is in grams or kgs per GDP. GDP, though the word is very familiar to all of us, the second one is the temperature rise. So we were supposed to limit the temperature rise within 1.5 to 2 degrees centigrade by 2027. So this I'm just showing how countries are performing. So if you see, some countries are performing very bad. Instead of 1.5 and 2, they are performing 4 degrees plus. So Russia, Saudi Arabia, Turkey, Ukraine, USA. And highly insufficient category, Argentina, Canada, Chile, China, Japan, South Korea, South Africa, UAE. Insufficient category, Australia, Brazil, EU, Kazakhstan, Mexico, New Zealand. These are all mostly rather rich countries, rather developed countries, you can see here. Less than 2 degree compatible. Bhutan is there, Costa Rica is there, Ethiopia is there, India is also there, Philippines. Okay. So both on the emission front as well as on the temperature control front, India is doing its commitment towards the Paris Agreement, vis-a-vis which is not followed by most developed countries, as we can see in column 1, 2, and 3. So countries which are performing better are only two countries, two African countries. One is Morocco, one is Gambia. Okay, so taking forward things. One more factor, I told you this, not only the Paris Agreement and climatic sustainability and all. One more very deciding criteria on fuel efficiency as being sought by the government is the reduction of crude import. So if your vehicle is improving its fuel efficiency by 5%, 10%, naturally a proportionate reduction in the crude import we can have. So about 85% of our crude is being imported, be it the Gulf countries, be it some of the African countries, be it South American, Venezuela or Colombia, those countries, 85% we are importing. If you look at the quantum, last 2 years, it's more or less we are consuming about 213 million metric tons. Total product, what is produced here in India is 262. So this difference, as you know, Reliance refineries mostly they are export oriented. Part of their supply is being distributed in India. Majority is being exported. Even otherwise, not only Reliance refineries, many refineries are sending their finished products abroad. So that is why this 213 to roughly 50 million metric tons capacity is being exported. And crude production in India is 34.2. So this constitutes about 15%, as I was indicating. So last year's figures, if you see consumption and petroleum total production is same, and production in India has fallen down slightly. And if you see this year's April to July figure, somewhere on similar lines. And of course, because of our lockdown and all, the figure should be on a pro rata basis, it will be less, I should say. And crude import as a percentage of total imports is about 25%. And value of crude import is about 7 lakh crores. So government is planning, okay, we should... Hello.
Participant, please mute your mic.
Okay. This is another aspect which has prompted which is prompting the government to enforce more and more efficiency in our automobile industry also. And okay, one more sentence which I was just going to complete was that by 2025 we are targeting a reduction of 10% crude import. So 10% crude import means roughly you can say 0.7 lakh crores of reduction, which we are targeting. Then coming to auto sales in India, 174 lakhs. This is all two-wheelers. You look at the numbers, 81% of total sales is two-wheelers, followed by three-wheelers about 3%. Then buses and trucks about 3%. Passenger vehicles, mostly cars, we can say 13%. So two-wheelers plus passenger cars, this together forms about 94% of our total sales. And if you look at electric vehicle sales, so last year two-wheeler electric vehicles were 1.52 lakhs total sales as against 1.26 lakhs of the previous year. As a percentage of total sales of two-wheelers, it is 0.87%. And some of the most popular brands, I can say TVS, iQube, Bajaj, Chetak, etc. And passenger cars, FY20 only 3,400 cars, a tad below the previous year, where 3,600 were sold. And if you look at the percentage of EV cars, it's only a meager 0.12%. And these names are all under electronic. It's on barrel. One barrel consists of 42 gallons or about 115 liters. So In the normal refining process, it gives out 47% of gasoline. Gasoline is petrol. Okay, 23% of diesel. 18% other products, it will include all that intermediaries like LDO, other intermediate stocks. 10% of jet fuel is jet fuel means it's as good as kerosene. So we have lesser and lesser kerosene and more of just jet fuels these days. 4% LPG, 3% asphalt. So the actual fuel requirement will not be in these ratios. So we need a country like India, we need more of diesel, less of petrol. And here again, these 18% of other products we would then essentially require to be converted into diesel, petrol, and maybe even a little more of LPG we may require. So how exactly these things are achieved in a refinery? Let us have a look. This is a typical distillation column of a refinery. So in the refining process, top you will get gasoline vapors, then LPG. Naphtha is essentially petrol, followed by that kerosene, diesel distillates. Medium weight is light diesel oil, etc. Heavy is furnace oil, etc. And the residuum, or tar, asphalt or tar, these kind of things. So if you stand near our Kochi refinery distillation columns, if you look up at any of the distillation columns, you can see a number of pipes coming down like this. A few columns will be going up like this. So these cross distribution and further distillation refining is for the purpose of taking. Here you can see this is petrol. Petrol is being further taken down for cracking, alkylation, and it becomes diesel or jet fuel or part of it petrol itself. LPG, because I told you LPG also we require more of LPG, not only the quantity which comes through a natural distillation process. And even this kind of refining process or the distillation process, even if you stand near a chemical factory or a fertilizer factory, you can see. So I am just giving some insight into the basic refining process, that's all. So from these will be the typical calorific values and conversion factors which we'll be using for. Don't worry, I'm not going to give you any big formula or conversion tables. Only like for understanding how are the fuels and their calorific values primarily. LPG, its density is 0.542. So 0.542 means 2 kg cylinder being used at our house. The total volume of LPG mix in that cylinder will be 14.2 divided by 0.542 means about 26. It has a calorific value of 11,900. Petrol has a calorific value of 10,850. Diesel 10,800. Kerosene slightly more, 11,100. ATF and kerosene are essentially same. So same calorific value. Light diesel oil 10,700. Furnace oil 10,500. And natural gas is having the highest calorific value of the lot. And it is the lightest also. Natural gas is lighter than LPG, needless to say, lighter than air also. So as a result, when we use natural gas as a fuel, either for automobile or even for our domestic cooking purpose, it is more safe. Why? Because even if any leakage happens, it escapes into the air and it goes up the level of air. So there is no potential danger which otherwise can be caused from an LPG cylinder. And if you see the states, Kerala state's energy consumption, or even for the nation or for the world, we can put. We have primarily the energy. When we talk of the first thing, what is coming to your mind will be electrical energy only, electrical energy. Then if you talk about efficiency, you will be thinking about LED lights or VFDs or solars or those kind of things. Okay, and we have petrol and diesel, then LPG and natural gas. Okay, so if you see last year's consumption of Kerala, if I convert everything into equivalent TOE, that is ton oil equivalent, with the formula 1 TOE MTOE is equal to 10 power 7 kilocalories of thermal energy, or 11,630 kWh of electrical energy. Or if you divide this by this, you will get 1 kWh is equal to 860 kilocalories, just for the purpose of easy conversion. So if you tabulate these total consumption of petrol in Kerala, diesel in Kerala, LPG in Kerala, kerosene in Kerala, then total electricity consumed by industries, households, commercial establishments, you will get the figure of total consumption of petrol plus diesel is 41.39 and 56% of total energy of Kerala. LPG 11.46, that is 16%. Electricity 20.4, that is 28%. Natural gas, as on date, it is a small figure, 0.22, that is 0.1% only. But in the days to come, especially since the GAIL pipeline is almost through, by virtue of this COVID situations and all, a few months delay has happened. I hope by November or December, the pipeline should go on stream. And associated with that, a lot of CNG filling stations are likely to come. PNG, that is piped natural gas supplies to houses, will come. So maybe after an year or two, if I'm showing this graph, I hope natural gas figures will be taking a quantum jump from this modest 0.1%, which I'm showing you now. Okay, so the purpose of showing this graph is, as I just told, anything about efficiency, we'll be thinking about electrical energy only. So you can very well understand the role of petrol and diesel, or the role of automobile sector in overall fuel efficiency, of overall energy efficiency is almost double. No? Almost electricity it is 28%, petrol and diesel it is 56%. So we should pay double the attention what we give for conservation of electricity and energy to save petrol and diesel. And the states figure I put. So I'll just take you to highlight the same factor, same figures, giving example of what happens in your house. In a month, how much energy is being consumed in your house. I can say in a month, 100 units of electricity you are consuming, an average house. That is 200 units per, that's a bi-monthly bill, 200 units. 200 into about 5 rupees, you take 1,000 rupees will be the electricity consumption charges alone. Add to that all your meter charges, other levies, duty, etc. About you get a bill of about 1,300 rupees, which I hope is common for an average middle class family of Kerala. Okay, so 100 units a month you are consuming. 100 units a month, I have equivalent kWh. I have put the same. So LPG, you know, it is 14.2 kgs. So typically, I can say a cylinder will last about 1.5 months, 45 days in your house. So in a month, let us assume 10 kg LPG you are consuming. 10 kg LPG, you just multiply with how much was the GCV I told, 11,800 or 11,900, which I showed you a few slides ahead. So if you convert into equivalent kWh, you will get 138 kWh of LPG. So in petrol and diesel, as you know, like many mechanical and automobile students here, you know, you will agree about 25 liters, be it a car plus a bike, or even at least a single bike alone. If you are traveling a reasonably okay distance, you will consume about 25 liters of petrol or diesel in a month. Same thing if you convert into kWh, you will get about 315 units of equivalent electricity. Okay, You add up, you are totally consuming 554 units of or 554 kWh of energy in your house. Just look at the percentages. Electricity is only 18%. LPG is only 25%. Petrol and diesel is 57%. So in the whole of Kerala, I have shown it as 56. Here it is 57. More or less same. So this amply justifies the need for bringing in efficiency in your everyday style of operating motor vehicles. And CO2 in some of the future slides, I will be showing you the CO2 footprint, CO2 generation by petrol and diesel per kg. If you burn 1 kg of petrol, you are emitting 2.64 kgs of carbon dioxide. Just apply any carbon dioxide, any petrol and diesel, it will be C plus H, CHA in all petroleum products. O2 plus N2, which is there in the air. Combustion process, it gives CO2 plus H2O plus nitrogen and heat. Okay, so 1 kg of petrol emits 2.64 kg of carbon dioxide. 1 kg diesel emits 2.39 kg carbon dioxide. LPG emits 1.67, CNG 2.40. Okay, and these two columns also some important data. See, I have mentioned about total consumption of petrol plus diesel in India is about total petroleum products. It's about 215 million metric tons all over India, and more than half, 115 million metric ton goes for petrol and diesel. In automobile sector alone, and it emits about 288 million metric ton of carbon dioxide. Just picking up from this. So considering the fact that tree absorbs about 20 kg of carbon dioxide per year, so we have learned in our schools and classes, tree absorbs carbon dioxide, emits oxygen. So a grown-up tree in an year, it can absorb about 20 kg carbon dioxide only. Okay, so if you in quantity 115 or 288 million metric ton of carbon dioxide, if you want to offset that with trees, we should have 1.44 crores of trees additionally every year, which will never happen. And as a result, the imbalance, or I should say the increased carbon emissions, the climatic changes is happening year after year. Today, okay, we are all entangled in this COVID scenario. Let's hope a few months from now, maybe a year max, we are coming out of it. And if you leave that aside, the most worrying factor for the entire world is the climatic changes. So just look around us. The climatic changes what is being happening in Kerala itself last 2-3 years. Okay, these are some things which we have never witnessed before. So it's right in front of us to witness the climatic changes. So like the big flooding what happened in Kerala 2 years back, we have almost forgotten, because so many other things bigger things have happened followed by that. We have almost forgotten what has happened 2 years back, and we have not taken any measure for countering that. It's a sad fact. Okay, then one more thing. What happens in our respiration? So average human being emits about 1 kg carbon dioxide per day through our respiration, which means he should have about 18 trees to offset the same, taking from the figure 20 kg. So suppose there are to offset the carbon dioxide emission through respiration itself, we should have 18 trees. So naturally CO2 level in the atmosphere will go up. CO2 in the atmosphere is about 500 ppm today, as against 200 ppm that existed 50 years back. And if you drive in an AC car with the AC interior air circulation on, if you drive for about 1 hour and all, naturally the carbon dioxide level from within your car, it will increase from this 500 ppm to 700, 800, 900. And if you don't allow the outside air to percolate into it at all, more and more carbon dioxide you try to inhale. And if the difference crosses about 550 ppm, that is 500, the natural ambient, and what you are breathing is something about 1000 plus, means you are bound to get that slight headache, giddiness, etc. That vomiting sensation, primarily because of your breathing, inhaling more and more air with large carbon dioxide content. Okay, let us, I hope I am not going slow. 3:20 already. Okay, I should move. This will be maybe one of the under this section, the penultimate slide. These are the policies being adopted by government for emission reduction, a long-term strategy 2010 to 2027. First one, this bigger, all these bigger chunks I'll talk about. This is EU mandatory vehicle norms is BS standard, I can say. Our petrol, diesel fuels have come off with higher refining, that is BS6 fuel. We started selling all over India from April 2020. Naturally, since the fuel itself is of lesser pollution, it gives a significant, making a significant contribution for this. Biofuels is the next big contributor. I have a slide next which I'll tell about that. This one is LCV infrastructure, is more to do with our electric vehicles, which I'll be talking about. And travel planning, you know, whether that trip is really required, you have to plan. Eco driving is a small line here, eco driving. Eco driving, only thing is, the highlight is that all these things are exterior factors, like government policies, what is available for you, the type of fuel, whether it is the availability of electric vehicle or availability of biofuels, everything is exterior factor. Whereas eco driving, it revolves around your driving skills, your driving habits. Though it is a thin line, this is something which you can implement, inculcate in your habit, in your driving habit. So that is why I will be talking about this towards the end. Speed limits, of course, if you travel in larger speeds, your fuel consumption will also be higher. Our club is carpooling, cycling tracks, etc. You know, dedicated cycle tracks are recommended in many cities. Traffic management is avoiding traffic blocks. Fleet efficiency improvement is, for example, railways these days, they started increasing the height of their container wagons by raising the electric pole side, so that larger quantum of freight can be carried. Freight model shift is like you can, for example, you can say the Sagarmala project, where maritime routes are being made use of. Green Bus Fund is many state STUs are being funded by central government for procuring electric buses. The workability of that, economic workability of that, again, I'll be dealing with in some of the subsequent slides. And having told about ethanol, since it has got a capacity to reduce pollution, there are two types of blending: 5% blending. Mostly, what we are seeing is 5% blending into petrol. 10% blending will be coming shortly. 20% blending is envisaged for future. From 2000, okay, these are all the, so at 5.5%, what is the quantum of ethanol required? 10%, what is the quantum of ethanol required? 20%, what is required? And total consumption of gasoline or total consumption of petrol, that is listed here. So we can say like even if we achieve 20% in 2020, 8.74, balance 35 will be normal petrol. So this tabulation is very simple. So what happens in ethanol blending? So this is the crop, typically sugarcane or sorghum. Sorghum is cholam. It goes for fermentation, purification. Ethanol is formed. Ethanol is C2H5OH. Then it is blended with the petrol at depots and terminals. It is transported. E10 is ethanol 10. E5 is ethanol 5. And it reaches the petrol. Ethanol blending. And the first part I have finished. Now we'll go to e-vehicles and battery technologies. Any questions as of now? You can ask now itself, because since we are talking the first few slides what I have shown is quite generic in nature. If you have any questions, you may ask that. Students, especially.
Does anybody have any questions? You can. You have a few minutes before sir moves to the next section. Does anybody have any questions? Please unmute and go ahead, or you can post your question in the chat box.
The chat box towards the end I will take. Okay, both the options are there. If you are asking now itself, I will try to answer, and in the chat box I will take it together towards the end.
Okay, sir.
Both options are there for the students. And shall I continue then? I'll
Yes,
wait
sir.
for 2.
Yes, sir. I think there are nobody's responded so far.
Okay. You can reserve your questions towards the end. Okay. Now let's come to e-vehicles and battery technologies. Hybrid car, as you know, to automobile student side, need not elaborate at all. Where both IC engine and electric engines are of late. Since the reliability of electric cars have come in force, so hybrid cars are largely being outdated, because it will have both the systems, and naturally the expense will be high. Initially start with ICE and then switch over to electric vehicles. That was the proposal. So only for academic purpose I have shown this here. Now for a pure electric vehicle, we will have a battery, DC cables, advanced engine technologies, charge module, power inverter, electric motor and generator, and accessory power module will be there. And regenerative brakes is something which, you know, like converts the useful kinetic energy into usable energy later on, which is otherwise lost in braking. Typical EV battery. As the vehicle goes bigger, the weight of batteries also will be quite high. Sometimes I have seen e-buses being manufactured at Leyland. So the overall weight, unladen weight, will be as much as, or maybe even slightly more than diesel-driven buses, because that much of I'll come to the battery properties and discuss about that. So that much of heavy batteries are in use now. So the area which needs the biggest R&D and technological application is battery technology of the vehicles, which all young automobile engineers and mechanical engineers, okay, electrical also I can say, can contribute. Typical components of an EV battery assembly adhesives, then a thermal gap filler will be here, thermal adhesives will be there, battery structural adhesives. Exterior fittings I am talking about. Active coating will be there, integration service will be there. And the different types of, we call commonly lithium batteries, lithium ion batteries. There are various types of lithium batteries. One is that is lithium cobalt oxide. Then we have LMO, lithium manganese oxide. We have NMC, lithium nickel manganese cobalt, lithium iron phosphate, NCA, lithium nickel cobalt aluminum. And all these technologies are used by different vehicle manufacturers, as you can see here. LCO batteries are used by Tesla, is a very common name, used in Daimler-Benz. Again used in Tesla Roadster. 56 kWh, you can say it is a what you call it's more of a heavy engine. It has to be any truck, you can say, or a bus for that matter. 16.5 is a car. Approximate range under normal driving distance 245 miles, about 350 kilometers, is about 120 kilometers. Then LMO batteries are being used. Manufacturers are LG Chem. You know, LG Chem in Hyderabad. Sometime back, there was a fire in that factory. Lots of people died under LG Chem. Just for bringing your attention, I'm just citing that example. Hitachi, Iwasa, Toshiba. So Nissan is using this kind of batteries. 24 kWh battery means this again a passenger car segment, about 140 kilometers, which runs on this. These are bigger ones, LFP batteries. BYD electric buses are were used by Ksrtc. Of course, it's not running right now. On primarily Ksrtc discontinued those owing to some commercial terms, not on performance or technological aspects. So BYD E6 were the buses used by Ksrtc, 57 kWh batteries, and it runs about 249 miles, about 360, 370 kilometers. So when it was operating between Trivandrum and Ernakulam, as a cushion, they had a top-up station at Haripad. The first day it stopped somewhere in between to avoid such kind of situations. They have kept a top-up station at Haripad. Then lithium NMC batteries were used by Hitachi, LG Chem, Samsung. So it is being used in BMW. BMW 35 is again a car because their cars are mostly quite powerful cars, powerful engines. And how we decide battery capacity and recharging distance? The following energies: electric bus, driving force plus friction plus wind, 140 watts per kilometer is required. Other axis watts per kilometer is the battery power requirement for a bus. Okay, so battery efficiency of 0.9 you can assume. So net power required is 50 divided by 2 watts per liter. Suppose 300 kilometers is the travel distance desired for a recharge. Then we will require 162 into 300, that is 48.6 kWh battery. So this is something on the lowest side. So if you have an air-conditioned bus and you are desirous of carrying your next charging to 400 kilometers, or with some cushion you want to take it up to 500 kilometers. So this 162 will go up to say 200. So 200 into 400, you will get about 80 kWh battery here, or even more. Like even some of the 12-meter JC air-conditioned buses having a long distance travel plans, they have batteries of 120, 150 kWh also. Lithium batteries, though we primarily all electric batteries, we talk about lithium only. But some more recent technologies are aluminum air batteries. Aluminum air batteries are primary cells, that is not. Once the aluminum anode is consumed by its reaction, and before that, whatever happening here, there will be an aluminum anode. Alumina is filled here. There will be an aqueous electrolyte, and air will be the cathode. So what they are saying is in this catalytic process, aluminum gets fully absorbed over a period of time by its reaction with atmospheric oxygen at a cathode immersed in water-based electrolyte to form hydrated aluminum oxide. The battery will no longer produce electricity once the aluminum is fully over. However, it is possible to mechanically recharge the battery with new aluminum anodes made from recycling of hydrated aluminum oxide. Such recycling would be essential if aluminum air batteries were to be widely adopted. This is not purely academic. So Indian Oil has set up an R&D facility for creating aluminum air batteries in tie-up with a firm of Israel. That firm's name I am not getting readily. And the performance of batteries. So what all are the factors governing selection of a battery? So let us start with the lead acid. Then nickel cadmium has come. Then NIMH. NIMH is nickel metal hydride battery. Then the lithium ion, which we are predominantly using now, and the lithium metal, or even that aluminum metal, which I was just mentioning about. And in the days to come, we can see more and more technology and R&D coming in these areas. So presently, lithium-ion batteries have about 150 watts per kg capacity. Two terminologies which is closely associated with performance of battery. One is the specific energy, and the second one is specific power. Specific energy indicates its holding power, or rather how much of energy can be stored in a battery. That is being indicated by specific energy. Specific power, on the other hand, it indicates ability to deliver power. So battery should have high specific energy so that even a small size battery can store a lot of energy, and low specific power, because once it starts high specific energy, low specific power. So this will give a longer runtime because a lot of energy is stored in it. Higher current, even if a sudden, like if you are using for a bus, a lot of load is there. You want to, this, you can say this is a kind of a sprinting, this is a kind of a marathon. So you should have a lot of energy stored in it. So sudden need of power the battery should be able to deliver that with a low specific power. That is, it has capacity to deliver higher current requirement also. So now I will just put a question. The lithium-ion battery I just indicated about 150 watts per kg is the ongoing capacity. What will be the weight of a 30 kWh lithium-ion battery? Suppose a small truck, a mini truck I can say, or a high-powered BMW car. It requires 30 kWh of lithium-ion battery. So what will be the weight of the battery pack required for that vehicle? I told you 150 watts per kg is the lithium ion's specific energy. If you want 30 kWh, 30 divided by 150 convert into kgs. It will give you 200 kgs of weight of batteries. So for a car, 200 kgs of battery weight, you can imagine. You just compare the battery weight of your IC engine car and 200 kgs of battery required for an electric vehicle. So the amount of battery space, weight of battery space occupied in an electric vehicle is something to be taken for the all design parameters for the time being. And these are the Ministries' guidelines on EV charging infrastructure. If you just quickly run through, EV charging has been recognized as a service. So MOP released guidelines on EV charging infrastructure, which addresses the need for adequate availability of charging stations on 14 December 2018. These guidelines were revised not October 2019. If you see again 8th June it was revised, and about 3 weeks back government further issued a notification wherein 236 identified stations not allocation. 236 stations have been allotted nationally. About 6 EV charging stations, big size, are going to come up in Kerala. Exact locations I am unable to tell right now. Okay. And these will be the charging methodologies. Charger connectors, CCS, SHADIMO, and Type 2 AC. SHADIMO and CCS are the most common charging technologies, rated voltage of 200 to 750 or higher. Mentioned for, particular for, useful for four-wheelers. And even, okay, this will be usable for not only four-wheelers, even buses and trucks also can be used. Buses, mostly it will be, okay, not 50, even higher capacities shall be adopted, but minimum of 50. And so I will not spend much time here. I will go to the next slide. BEV charging, there are primarily two methods: conductive charging and inductive charging, and of course battery swapping. So from the grid, there will be transformer, AC to DC conversion. From a DC or DC, power is being extended to the vehicle. So charging technologies: conductive charging, charging. It's the same terminologies what you study in engineering: conduction and induction. And of course, I have seen many buses pantograph on top of their this thing, like it will be folded. So charging happens within 5-10 minutes. Delivery is 300 amps, 400 kWh. And then typically we have three modes which I mentioned in the previous graph itself. Normal charging, AC 110 volt and 220 volt, means which you do at your house. 6 to 10 hours of charging, useful for three-wheelers, small cars, big cars also. That is the Hyundai or MG Hector. Their cars also have a domestic charging kit also. Only thing is that at home it will take 5-6 hours even to build up to say about 50%, 60% capacity. So every day you will have to charge at home, even for a modest use of your car. Otherwise, if you are going for a dedicated charging station, your 100% charging can be had within a time period of 15 to 20 minutes. So fast charging 15 to 30 minutes is not possible in your house. Suppose your EV car with a 24 kWh is the battery capacity. If you want to charge within 15 minutes, so you will 24 divided by 1/4. That is 96 kW requirement is the power consumption which is not available in your house. Battery swapping, of course, the weak battery is getting replaced with a fully charged battery. Same thing, elaborated 16 amps AC single phase, useful for this is typically your two-wheeler or three-wheeler, 3.7 kW. It may take about 5 hours. 32 amp three phase, you can have it at your house, 22 kW or less. That is small cars. And 63 amps three phase, ideally you will have to depend upon whatever kW means, you will have to depend upon charging station. Up to 0.5 hour is required. Last one, 400 amps DC is our pantograph, high voltage, 200 kW or more capacity batteries, requiring about 6 minutes charging time. Another important factor on battery technologies is the price of battery. So, be it a two-wheeler, be it a car or truck or a bus, in an electric vehicles in today's rates, about 40% of the total vehicle cost is the battery cost. So, as regarding two-wheelers, EVs and electric two-wheelers and our normal petrol two-wheeler will cost alike, or a scooter will cost alike. So I'm not talking about the high-end two-wheelers which may cost lakhs. So typical average about 60,000, 70,000 I am comparing. So both will cost identical. Even in that, battery cost of a two-wheeler will be about 20,000 rupees. So 40% of 60,000 to 24,000, which the same thing which I was just mentioning about. In a bus costing about 1.75 crores or so, battery cost will be about 35 lakhs to 40 lakhs. So over a period of time, battery costs have come down steadily. So 2019, somewhere about $156 was the price. So it is expected to come down further. So people say if it reaches about $100 per kWh. So if you require about a 100 kWh battery for a bus, 100 kWh into 100 into 75 rupees is the dollar to rupee conversion. So it will cost about 75 lakhs. Okay. More more reasonable. So 75 plus about other bodybuilding things about you add about 30 or 40 lakhs, about 1 crore roughly, or 1.2 crores max. You can get a bus as against a price of 1.75 crores, which is the governing price as on date. And lot of technologies, all young engineers, electrical, mechanical, automobile, lot of scope is there in the EV battery development. Battery temperature management service, battery BMS, the overall battery management system. Lots of opportunities are being opened with the advent of EV vehicles to the mainstream. So lithium-ion batteries price outlook 24. I just mentioned like somewhere about 100. So that barrier is expected to be beaten in 2024. 2030. 62 it is expected. So if it comes to 62 and all, then IC engines will not find any place at all, because even beneath 100, beneath 90, it becomes almost poised evenly. So any decrease further on battery price, it will be advantage e-vehicles. And as regarding battery vehicles and cleaner fuels. So this I am showing because in my first slide, I have first or second slide I have shown initial slides. Somewhere about 98 grams per kilometer is the carbon emission per kilometer. Per kg, what I have shown there, I have shown only about roughly 2.5 kg per 2.5 kg carbon dioxide per kg of petrol diesel roughly. Okay, so you assume 1 kg of petrol or diesel is taking you for about 20 kilometers. So that 2.5 divided by 25, that is this figure. Okay, so 98 grams. So 2.5 divided by 25 will come about 0.1. 0.1 into 1000 is 100 grams. So that is the figure shown here. Equivalent petrol vehicle, one slight mistake I did. That calculation about is here about assuming about 15 kilometers mileage for your petrol vehicle. About same mileage diesel vehicle, it will give 125. And battery EV per gram, that is, it is brought in from per kWh how much carbon dioxide is being emitted. So about the third slide, fourth slide, which I showed, our carbon emissions from our power generating stations. So this is 98. So petrol and diesel gives about 125, 135 range of emission. CNG somewhere about 180. Okay. So even as per the present emission norms, battery EVs are emitting lesser carbon dioxide. Not that battery vehicles per se is emitting from its tailpipe, because it doesn't have a tailpipe, it doesn't emit carbon dioxide also. What happens is the power it consumes for charging its battery is being equated to equivalent carbon dioxide emission from a power generating station. So that is how this figure 98 grams per kilometer is being brought in. And these are all the harmful emissions from petrol and diesel happening, that is carbon monoxide, hydrocarbons, NO2, NO3 emissions, particulate matter. So all these are zero for electric vehicles. So I have told you already, we are getting BS6 fuels, which is highly refined from last April 2020. So the purification, what has gone into is reduction of sulfur, reduction of carbon monoxide, reduction of hydrocarbons, reduction of NOx in those fuels. And all these are zero for EVs, and marginally exist for petrol, diesel, and CNG. So both on account of carbon dioxide, other harmful emissions, electric vehicles are always preferred. This is more of academic. So if you want to calculate how much of carbon dioxide is getting generated from a non-type of fuel, so the calculation is one I will explain. So for diesel, I will explain. So 1 liter of diesel weighs about 835 grams. Okay? Diesel consists of 86%, 86.2% of carbon, or 720 grams of carbon per liter of diesel. In order to burn this carbon to CO2, 1920 grams of carbon, 1920 grams of oxygen is required. That is the formula C plus O2 equal to same, that molecular weight you compare, that's all. The sum is carbon, what is there in the fuel, additional oxygen required. So together 2640 grams of carbon dioxide per liter of diesel. Average, you can take 5 liters diesel for traveling 100 kilometers, then corresponding emission will be 132 grams of carbon dioxide per kilometer of travel. So same thing for petrol and LPG I have given. So petrol, it is slightly lesser, 120 grams per CO2. LPG, it will be still lesser. And natural gas, okay, the figure will be comparable somewhere here, somewhere between 130, 128, 130. On account of two aspects. One is it has got higher calorific value, that is 13,500 diesel. It is about 10,500 petrol and diesel. It is there. And emission lesser. Again, price of natural gas is lesser. It costs about 55 rupees or 57 rupees today per kg, as against 75 rupees, 80 rupees of diesel or petrol. And in the days to come, this is the present 2016 0.732 gram kg per kWh was there, 732 grams. Further come down to 580 by 2022 and 522 by 2026. These equivalent carbon dioxide per kilometer travel of electric vehicles becomes 98 as on date, which I showed in the previous chart. It is expected to come to 78 by 21-22, to 70 by 26-27. So this charts I have shown to alienate the allegation, or that many people say what we save in what you call petrol and diesel, equivalent or more is being burnt for generating that much of power required for charging of the battery. That apprehension is wrong, which is amply established in this slides. And new opportunities in auto industry, EV powertrain subsystems. It is opportunity to create or grow electronics hardware industry, battery module pack, creating manufacturing jobs for batteries and energy storage industry, power electronics. This is always there, whether IC engines or electric vehicles, is there. Lightweighting technologies. Lightweighting is one of the key necessities for EVs and can provide growth to the aluminum and chemical industries. And the software, of course, EV model requires millions of lines of software code to operate, creating jobs. And if you look at the branch-wise field of engineering, chemical engineering, manufacturing of lithium-ion cells, manufacturing of assembly of battery packs, recycling of batteries, or even not only lithium-ion. I have also mentioned about metal-ion, aluminum-ion batteries. Computer science and engineering, developing algorithms for battery management systems, making IoT module for sharing real-time data generated by EV, using AI to improve efficiency of the BMS. Mechanical engineering, additional what is existing, I am not mentioning. Thermal systems, vehicles and parts design and manufacturing. Electronics and communication engineering, developing firmware for battery management, developing infotainment system, manufacturing and installing sensors in the vehicle, power electronics. Electrical engineering, working on motors, quality control, testing of battery packs, developing wiring multi-port functions in the EV charging solutions. Mechatronics, vehicle design, robotics for parts assembly, powertrain component development. And those who are interested in e-vehicles, there is under this NPTEL, National Program for Enhanced Technology Learning, correct. Fundamentals of electric vehicles is technology and economics is being offered by IIT Madras. A course to understand is especially in Indian context and technology associated with each element of EV drivetrain. At the same time, it will get into economics of EVs. Students, pre-requirements none. So those who are interested may look into this. One aspect which I need to mention is, so far I have mentioned about e-vehicles only. Another subject is another type of fuel which is again not to be neglected, which is having a lot of hidden potential and reduction potential is CNG. Latest addition to CNG is hydrogen CNG, where 82% CNG is mixed with 18% hydrogen. So one station has already come up in Delhi. Its properties, it further reduces emissions. So NOx emissions is reduced by 50%. NMHC, all details, all other methane, THC, carbon monoxide, all are known to show a decrease by addition of hydrogen mixing in CNG. Then so our sustainability, we talk about, Mother Earth, we should contribute our bit. So the simplest thing what you can do is you buy an electric scooter in place of your petrol scooter. Or the economics of a two-wheeler electric scooter I am working out here. So price of petrol 75 rupees I am taking, average of last 6 months. Okay, price of electricity per unit 6 rupees I have taken. So e-bike, it takes about 1.2 units of electricity per charge. So you are traveling say 1,000 kilometers a month or 12,000 kilometers annual, and I am taking a analysis for 3 years. Lithium-ion batteries every 4th year you may require a replacement, that is 20,000. So I just mentioned 60,000 is the cost or 70,000 is the cost. 40% of that roughly 20,000 will come to the battery, whether it is small two-wheeler or four-wheeler, it doesn't matter. So 4-year driving distance will be 48,000 kilometers. I'm just comparing here e-bike, how is it performing, petrol bike, how is it performing. So cost of vehicle I'm assuming same 60,000. So range per charge, so it goes about 60 kilometers with a full charge. This goes about 50 kilometers with 1 liter petrol. Maintenance cost, this is hardly anything. However, I am putting about 3,000. So here I am putting about 12,000. Battery cost, it happens after the 3 year, 20,000. Units of power consumed is 816 charges. I am assuming for 60,000.
Participant Arjun V, please mute your mic. Arjun V. Sorry, sir.
Okay, let's go. Yeah, no issue. So about for this traversing this 48,000 kilometers, about 816 times you are charging. 816 into 1.2, 973 units of electricity is being consumed. Same thing at 50 kilometer per mileage. 50 kilometer mileage, you will require 960 liters of petrol. Electricity cost 5838 will come. Petrol charges 72,000 will come. So the 3 years life cycle. For an e-bike, it is 88,000 or 89,000 you take. For a petrol bike, it will be 1,44,000. The simple economics, it makes sense. If you can go for a two-wheeler electric vehicle, it doesn't lack in elegance, but at the same time, its contribution for financial aspects, emission aspects, or sustainability aspects, is some simple thing which you can contribute. And what I have listed here is the mileage aspects of electric buses. So you get typically 9-meter chassis and 12-meter chassis are there. 9-meter chassis, naturally it will be capacities, lesser cost. It gives about 0.7 to 0.8 kWh per kilometer. So it is non-AC. So HVAC system present are these. Tata Motors, the same one with AC, it goes up by roughly 30%, you can say. So I have written here. With AC, it will be 30 to 40% more energy. So non-AC, you can say, non-AC buses, it consumes about 1 unit per kilometer. And with AC, it will consume somewhere about 1.3, 1.4, 1.5 units per kilometer. And some of the Indian makes, that is Leyland and Tata Motors, you can see it is comparatively less efficient. It consumes 1.3, 1.4, 1.7 to 2. Photon e-buses are also there in India, imported buses. These are quite energy efficient, 0.83 kWh per kilometer only. Okay. And of course, all you young engineers have a role to play. These to be brought comparable with these figures, somewhere close to 0.8, 0.9 kWh per kilometer. Battery performance, as you know, it's not like our mobile where you allow it to fall to 0%, then charge it for some time and take it up to. So always 30% reserve battery capacity is kept, minimum SOC in the battery. Then owing to this is 30%. Then owing to range anxiety, whether we can reach that. So it's say 300 kilometers. I have a recharging station, so we will not drive exactly keeping exact 300. So we'll have an additional 15% cushion. So only the remaining part is the usable charge. So total usable charge 85% of this 70%. So 70%. This is the range anxiety element. 30% is the minimum capacity to be allocated buffer. So 85% of 70% is the, about roughly 60% is the usable capacity of a battery. And this is for primarily this comparison is useful for any STU. Any Ksrtc wants to buy a new, what cost it will be viable? If it takes an option whether to buy a diesel bus or CNG bus. So how we will do? We'll go for a life cycle analysis. Typically, life of a bus is kept as 10 years. Of course, beyond 10 years also, most of the STUs run it. Maybe they change it from express and superfast to ordinary. That's the change. So I have taken 10 years as the life cycle period. 9% is the interest cost taken. Cost of acquisition of an average bus, diesel bus is about 28 lakhs. CNG bus, you can take about 35 lakhs. Electric bus, about 175 lakhs is today's cost. And if the battery cost and primarily if battery cost itself comes down, 25% reduction happens in the e-bus cost, means about 130 lakhs. This is a fictitious case. 1, 2, 3 are the today's prevailing rates. Fourth one is the maybe down the line, 2 years, 3 years down the line, it will happen. So typically a bus will run somewhere between 300 to 400 kilometers. A bus in good condition, it will go for 400 kilometers. And buses with slightly old engines and all, they keep it for about 300 kilometers, 350 kilometers run per day. So if I am assuming 400 kilometers and it runs for 360 days, 1,44,000 kilometers will be the running per year. Type of diesel, CNG, electricity. Fuel consumption 4 you can take conveniently as the 4 kmpl for bus diesel. Slightly improved kmpl for CNG. 4.25, 4.5 are experienced by Ksrtc or any CNG buses for that matter. 1.4 is the case with AC. 12 meter chassis, like same capacity electric bus. And fuel price 70, 56. Okay, these figures have undergone some 20% jump in the more recent times. These were the figures which I took about 3 months back, 4 months back. Anyway, it will not matter much. So maintenance cost for diesel bus will be about 4, and heat of combustion for CNG is more. So naturally, the piston rings, etc., gets worn out little faster for CNG. 6 rupees per kilometer, I have assumed. Electric buses, not much. However, 2 rupees maintenance cost per kilometer I have taken. So operating cost is the diesel cost for that matter, or CNG cost. 176 lakhs for diesel, 121 lakhs for CNG, 91 lakhs for electric bus. Maintenance cost, that is 6 into kilometers. It will give 5.76, 8.64, 2.88, 2.88 per year for a period of 10 years. Like it's a life cycle cost. It's not that 10 into 5.76 is coming. When you put it in a life cycle analysis, you will get a net cost as 36.97 for diesel bus, 55 for CNG, 18.5 for electric bus. And insurance cost and scrap value, I am just assuming. So with these figures, you will get 241 lakhs as the owning cost for a diesel bus, 211 lakhs owning cost for a CNG bus, 286 electric bus at today's cost, 235 if the price reduces by 25%. So with the 25% reduction, electric buses are comparable with diesel buses and CNG buses. And this is the breakthrough. This is the point which we are looking forward to. Okay, and if it comes like 25%, means it will come to 130 lakhs. So I have just mentioned if it comes to 1.1 crore to 1 crore level, definitely electric vehicles will be beating diesel and CNG buses through and through. Okay, and one more interesting factor is we mentioned about the star rating of ACs, fridge, or even star rated fans and lights have also come. So a number of household items, the star rating, B star rating in place, like 4-star, 5-star will give better efficiencies. BE has also brought in efficiency standards for fixed chassis, that is rigid vehicles, N3 rigid vehicles, with tonnages above 12 tons. So vehicles falling 12 to 16-ton category, axle configuration 4x2. This is the equation. Y equal to 0.362x plus 10.327. Fuel consumption is liters per 100 kilometers. So with an example, we'll see here. Take the example of a bus 12 ton as its unladen weight. We shall consider two cases with 30 passengers and 60 passengers. Assuming per passenger weight is 60 kilos, 30 into 60, 1,800 kilos in first case, 3,600 kilos in second case. So this is a classic example of today's restriction on buses with COVID scenario. You load only 50% of passengers. So that is why exactly I have taken 30 passengers, and second case, the case which was existing, and with the case which will come back after say few months. So applying this formula, first case 0.360 into 13.8, that is 12 plus 1.8, 13.8 plus 10.327 equal to 15.32 liters per 100 kilometers. If you convert into kmpl, it will come to 6.53 kmpl. And in the second case, fuel consumption 0.362 into 15.6, that is 12 tons weight plus 3,600 kilo weight of passengers. 0.362 into 15.6 plus 10.327, it will give 15.97 liters per 100 kilometers or 6.26 kmpl. So the decrease in kmpl with passenger load is 4% only, 4.1%. So this we had some time back done some depot efficiency study, fleet efficiency study for Ksrtc, where the impact of this passenger load vis-a-vis the KMPL performance were also studied. There again, we got this by plotting plenty of best fit curves. About 4%, 5% is the only variation with even a large increase or decrease in passenger loads. Okay, this you just keep in mind, we saw only 4% difference in mileage. Next case, we will see what happens if two different speeds are adopted, 40 kilometer speed and 60 kilometer speed. And sorry, it's already the calculation is here. This is this 40 kilometer speed is the case here. Next is 60 kilometer speed. When it is 60 kilometer, the formula varies. It becomes 0.788x plus 9.003. Same case, that is 12-ton bus with initial 30 passengers. Second case, 60. First case, it becomes 0.788 into 13.8 plus 1003. 19.88 liters per 100 kilometers. The mileage reduces significantly. It comes to 5.03 kmpl. And in the second case, it comes down to 4.69 kmpl. So the two speeds are compared here, 40 kmph and 60 kmph. First case 6.53 and 6.26. Second case 5.03 and 4.69. With reduction in speed, or rather increase in speed from 40 to 60, the mileage has reduced to 23%, 25%. Whereas with the passenger, the role of passenger, the impact of passenger load is only about 4%, whereas speed has got a significant role to play in the mileages of vehicle, be it a bus, be it a two-wheeler, be it a four-wheeler. The last part, okay, I'm not waiting for your questions, you can keep it towards that. Last part is improving your driving habits. I hope whatever I mentioned till now is more to do with more of academic, and hereafter whatever I am going to talk is about the driving habit of you and me. Okay, so I am assuming we have about 100 participants here. So if a particular make and model of a car and 1 liter petrol is given to 100 participants, we know 100 participants will be driving or getting stopped at different distances. Suppose it's a Maruti Desire petrol. You may assume, okay, 16 kilometers, 70 kilometers, somewhere, almost everyone will be falling in that 16, 17 kilometers. But I'm telling you, some drivers will be there who will be crossing not only 16, 17, even 18, 19 and close to 20 also. Some drivers will be there who will be falling way behind, finishing in the range of 13, 14, 15 also. So we conduct a lot of when we conduct that oil conservation activities and all, driving competition for drivers. We tie up with some. They select a cluster of their clients. So we want the same, like a particular model of their engine CC will be same, brand will be same, sold during a period, say between 2015 to 2017, or say 2018 to 2019. So we will get about 20 or about 15, 20 customers will come for competitions. We will take in order to give identical travel pattern, we will select some routes with lean traffic, maybe island side of Kochi, or some if you go to Kollam, that Asram ground is there, where very lean traffic. Everyone will be driving in identical test conditions. So we will take all these vehicles to petrol bunk. Engine, all tanks will be topped up and sealed. Okay. Thereafter, the actual kilometers are being run. So about 60, about maybe 30 or close to about 30 kilometers will be the running distance. They come back to the same bunk. Again, the actual quantity required for topping up for this 30 kilometers will be measured, and the winner is decided. So invariably, what we see from the median, the prize winner will be top 1 or 2 or 3 drivers will be about 40% to 50% above the median, and the people who finished last will be same way, 30%, 40%, 50% below the median, or in effect, the difference between the first and last will be somewhere between 75% to sometimes even somewhere between 60 to 80%. We have noted many times. So that much of difference in driving exists in our driving habits. So when we go to driving school and learn and get a license, the only intention of the driving school driver instructor is that you shouldn't fail in the test and you should get a license. The fuel efficiency part is never looked into, never taught, and unless otherwise something goes into your mind, you will never practice it also. So I will just try to give some of the tips. The time is already close to 4:20, so another 10-15 minutes I will cover it up. And as you drive a cycle, okay, everyone drives a cycle. So I'm not asking a question how many of you have a driving license. So you are driving from Karagutti to NH to your college, say 5 kilometers. So when you drive a bicycle, you will stop pedaling when all. So I'm not asking your answer, because one is as you reach a slope, down slope you reach, you will stop pedaling. You have to stop somewhere, of course, no pedaling. This part you will stop pedaling when your cycle has attained certain speed, and that kinetic energy takes you forward, for which you don't have to give a pedaling at all. Same principle applies for your vehicle also. You have for vehicle, giving pedaling is what you call your pressing accelerator. I mean, you are causing injection of fuel into the combustion system. So the moment you stop giving accelerator, your stop pedaling has come into place. So the same thing applies for your car, bike, lorry, truck also. So that red line. So I'm not I'm not explaining every small things here. I will just go here. An average driver, lots of acceleration and braking. That by this red graph, you are getting converted into a smoother eco driving. Smooth acceleration, steady travel, smooth deceleration. So driving at constant speed is something important. It may not always be possible. Try to maintain a constant speed. It's not that you travel at 40 or 50. Even if you want to travel at 60, 70, which the road permits up to 80 kilometers, drive at 80 kilometers. Then again, there is option for fuel saving. Freewheeling is something very important, which I will tell in detail in the next slide. Stop idling is okay if your car is stopped, but if you're driving in AC in a hot climate, don't switch off. You continue to be in that condition, doesn't matter. This is okay, like the same I just mentioned about not giving acceleration. This vehicle, it has a certain kinetic energy. So even before reaching the or this top point of this hillock, you can stop giving acceleration here itself. The existing the gained kinetic energy already takes the vehicle forward. It carries down the hill, and again you will have to apply accelerator at this point. Okay, and okay, now you students already know these are all the vehicle, forces acting on a vehicle. driving force will be there, braking force, aerodynamic force in the opposite direction, gravity force, and rolling resistance. I will neutral versus gear. So these two, while you drive in neutral, whether you will be gaining most, or when you drive in gear, you will gain most. This is the comparison. Suppose clear traffic, clear road. So on a Sunday, you are driving from your college up to the national highway. There may not be much traffic. So you have the option. You part of the distance neutral, part of the distance. I mean, like the same thing with gear. With gear, if you are not giving acceleration. So these two are the two cases which I am going to compare. That is, one is you are in neutral. Second, you are in gear but not giving acceleration. Which case will be more fuel efficient for you? That is a question. So had it been in a one-to-one this thing, I would have asked you people to raise your hands. Then and everywhere, both the answers come. I will explain here. Since many of you are automobile and mechanical, the answers will be more correct, as which I expect. So typically, this is a vehicle. There will be an engine. There will be transmission. Differentials will be there. Wheels. Okay. So first case, I'm taking this. So you are traveling at about 60 speed. So with an intention of saving diesel or saving petrol, you are turning to neutral and going. That vehicle is going. You were going at 60. You, instead of putting in a higher gear or lower gear, you are making it neutral and going for some distance. So it's even otherwise. Okay. In the national highway also, the first signal you are going to see. So about 100 meters or so, 150 meters or so ahead, you have a signal. So what you will do in order to save fuel, you take a case. Okay, first case, you are traveling the distance with your vehicle in neutral. Second case, you are traveling the distance in your gear, say third or fourth or fifth, whatever. In fifth gear, it may not take you till there. Third or fourth gear, you are traveling without accelerator. First case, what will happen if you are neutral? So your vehicle is traveling at 60. Your wheels continue to rotate at 60. It rotates the differential, it rotates the transmission, and the transmission rotates the engine since it is coupled. Or in other words, the engine rotation is being achieved through the rotation of the wheels or the kinetic energy of the vehicle which is already built in. So this fact, first, I explained, I was talking about neutral. The case I explained is gear. In that case, okay, when you're in gear, tire rotates the differential to transmission, transmission to engine. Engine transmission is achieved through tire rotation. If you are in neutral, what happens? All these parts are clear, but transmission to engine, it will not rotate because it is disengaged. So in that case, engine continues to get fuel supplies at the idle speed rate. Whereas in the first, while in gear, it doesn't require any fuel transmission from the pumping system, since the engine rotation is taken care of by the kinetic energy of the vehicle already built in. This you can very clearly observe if you have that KMPL reading in your car. That consumption falling to zero can be seen in car. Certain cars they don't show zero. Like for example, Micra, if you drive, it will not show zero. It will show as 30 kmpl. 30 kmpl, it's stagnant there. Whereas some other Ford, you drive any of the 1500 cc vehicles you drive, there you can see the needle falling to zero fuel consumption. That is 0 L per 100 km. You can physically see. Even when you drive along national highways, you are able to do that freewheeling, cruising. That is not cruising. I don't mean that auto set cruising. Cruising is you are driving in gear without giving accelerator. That is one underlying principle about gaining high mileages for your car. The same principle as I told you about a cycle. You stop pedaling when you have adequate energy built in. Same way, your energy you make use of by not is you will be using zero fuel if you are in gear and without accelerator. That is a point to be kept in your mind always. And next question is how much distance you will be able to travel by taking legs off your accelerator. So if you look at the forces acting on a moving vehicle, F equal to mu into mg, that is the kinetic half mv square, which is there in the car, is getting converted as mu into mgd, where mu is the rolling friction. So by equating, you will get d equal to v square by 2 into mu g. Suppose you are traveling at 60 kilometers or 16.7 meter per second speed. So d will be 16 to 16.7 divided by 2 into this. I'll just bring you back here into g. So this 0.01 I picked up from the next. It's the coefficient of rolling resistance. As you know, it's not the static, the rolling friction which is coming into play. So depending upon the speed and the tire pressure. About your car, you can say about 35 is the PSI, means about 2.5 or 226. 2.5 will be the bar pressure. 1.5 and 60 speed. Somewhere here. So that is why I have taken 0.01. So this will give theoretically a distance of 14-15 meters. So you know your transmission efficiency is about 12%, somewhere between 12%. So it's a case where engine is not running, you assume 12% efficiency. So 14-15 into 12%, about 170 meters. So if you are on a level road, you are traveling about 60 kilometer speed, you will be able to travel about 170 meters freewheeling without going accelerator. You can physically see. So not on a heavy traffic road. When the road is somewhat clear, you can see. You can physically see it on your dashboard. Your needle falling to zero, and without going accelerator, you are traveling about 170 meters. So these 170 meters you try to maximize in your journeys. So if you are traveling at 70 speed, so you are going to along that Palakkad road and newly built NH. So you may be traveling at 70, 80, which the RTO permits. You travel at 80, it doesn't matter. But you, as and when possible, you stop doing accelerator fully. Then golden rules: anticipate traffic flow, maintain a steady speed. It's not that you give accelerator, reach 60, some vehicle, you can just, some stop is coming ahead, you put a sudden brake, you know some braking has to be done by virtue of some humps or something, all the acceleration what you gave is getting wasted. So try to keep a steady speed. And then very important principle, more than looking at your speed, you try to look at your RPM. The lowest RPM will always give you the best KMPL. So lowest RPM, highest gear. That is the combination where you will get the best KMPL. So this is the principle. From 16 KMPL you want to develop to 17, 18, 19, 20. You start looking at your RPM also. The earlier shown taught principle, that is, don't give accelerator unnecessarily. These two itself will take you to better KMPLs. Shift up early, engage your gears as far as higher gears, try to reach at the earliest. Tire pressure, if it is low, it is another contributing factor. 5 to 10% KMPL can be brought down if you are not filling adequately. Don't overfill also. That recommended, whatever it be, 35 to 40 PSI, whatever is recommended, you try to maintain. Unnecessarily don't consider any extra energy, of course, extra baggage, extra luggage, etc. Try to avoid. These calculations are applicable typically for a car. First gear it gives about 7 kmpl, second gear it gives about 10 kmpl, third gear is 12, fourth 15, fifth 16, sixth gear if it is there. So up to here we can compare. So third to fourth, 12 to 15. This is very important. Fourth to fifth is only 15 to 16. So you shouldn't be driving much in 3. So you should try to bring or drive more and more in 4th and 5th. Of course, as your expertise will tell you which is the right gear. So if at low speeds in a traffic, thick traffic, you try to go in fourth gear, fifth gear, naturally knocking will come, which is not desired at all for the vehicle. Same thing, like even for a truck, you try to bring in the lowest RPM. Like even this graph can further be shifted leftwards. So 1200 RPM will be more desired. And with eco driving, all other like emissions also. These are studies conducted on third gear, fourth gear, fifth gear for varying engine capacities. 1200cc engine, whether it is a 2500cc engine, the results are almost same. Third to fourth gear, it's about 22% reduction in consumption. Third to fifth, with 35% reduction in fuel consumption. So this is like signifying the need for shifting up early. And carbon monoxide, 78% reduction. Carbon, 63% reduction. NOx emissions, 50%. So 45, 55 is one of the old rules. So I have told you 60, 70, 80 also you can go, provided you try to avail that freewheeling. These, okay, maintenance, vehicle maintenance, etc. These things I need not elaborate. Right, gear selection, and always start with clutch pressed. Not only being in neutral, as automobile engineers, you know, with clutch pressed condition, you are giving lesser weight to the starting motor. Don't do clutch driving, drive in correct gear. Okay. All these things I already mentioned, the correct grade of fuel, and of course, to automobile engineers, I need not elaborate all these things. Okay. Planning, right, correct methodology, carpooling. Then, okay, this I'll just explain quite fast. Like studies conducted in upcoming cities, not Delhi, Bombay, and all. Upcoming cities, use of public transport. It's only 9%. Whereas all other cities, you can see at least in double digits. Taxi and cab, 26%. Auto, 32%. Vehicles, 25%. Now, in this COVID era, of course, personal vehicles have gone further up. Public transport has come down further. But even otherwise, Kochi has got a low usage of public transport, which is not so desired. So Bangalore, for that matter, is a city where public transport is quite well established. Last November, they started dedicated bus lane. So this is a bus carrying 70 people. Same 70 people lined up in own vehicles, two-wheelers and cars. You can see the difference. Stage. That's all. I think now I will leave the platform for questions.
So if participants, thank you, sir, for the webinar. Participants, if you have any questions, you can unmute your mic and you can interact directly with Suresh Kumar, sir. I think I will go ahead and, sir, I have one question regarding ethanol.
Yeah.
So you had said that there are different types of batteries are there. So which is the most consumable battery in these batteries?
Of the 4 or 5 types which I mentioned.
Yeah.
But 4 or 5 all are different. OEMs are using different batteries. So I don't think anything specifically I can pinpoint. Maybe I'm not all that expert also, because in that one of the slides I have shown like Electra is using that, BMW is using a different kind. All 4 or 5 batteries are being used by OEMs. So individual exact property wise, I am also not very sure. But I can only say different technologies are being adopted by different OEMs.
So it depends upon the specs of the engine or the power of the engine.
Yeah, that matters. It matters because that one chart I have shown that specific energy requirement also. Like batteries with some of the trucks for the trucks it will be like higher specific power will be required because it carries a lot of weight. As for passenger vehicles, the big battery technology with which is having larger specific energy, like more of a distance to be covered, will be the criteria. These are the important governing aspects regarding the selection of batteries.
So another, I have one doubt also. I have one more doubt.
Please.
So you have said that there's an electronic bus that having charging very fastly, like train.
Pantograph.
We can see.
Yeah, pantograph. Okay.
Is that method can be used in a car too?
Car, it's not required because these buses have batteries of maybe 120 up to 200 kWh. So in normal process, of those buses will take lots of time. That is why 200 kW to 200 amps up to 400 amps 200 kW power is being, which will charge in 5 minutes or 6 minutes. So it's okay. Cars 10-15 minutes fast charging. It will come down further to maybe 8 minutes, 10 minutes in the coming years. So cars, we don't have to go for that. Not only carrying such a thing on your car, it is dangerous.
Oh, okay, sir. Okay. So can you send this presentation for us? That it may be useful for our study.
Surely. No doubt at all.
Oh, okay. Thank you, sir.
Fuels, there is I'll just go through. What about hybrid battery? Hybrid uses both the technologies like IC engines and it will have both. IC engines will have its own battery, electric part will have its own battery. So both are mutually exclusive. So fuel cell is that is again what you call the next stage of fuel cell. You can say I mentioned about metal ion. So metal ion is the starting point of fuel cell. You can say again hydrogen batteries. Those two will come as the fuel cells. Lots of R&Ds into fuel cells, but in present day fully fuel cell vehicles are not there on road as from what I know.
Sir, when it comes to ethanol, ethanol percentage in fuel. So in BS6, what is the percentage, sir? I think there is ethanol in BS6 fuel.
BS6 10%.
10%. Okay. So, sir, so can we the next fuel BS7? So there'll be a gradual increase in the percentage.
The desired or the targeted maximum is 20%. Okay. And ethanol is not all that cheap, but so I'll just elaborate something here because today's rate ethanol is about 55 rupees per liter, you can say. Okay. And there is one more technology going on at many refineries, not there at Kochi refinery. The reason is that Kerala is not an agricultural state. Panipat refinery is the biggest facility. Panipat, it is in Haryana. Hello. Delhi and Haryana are two biggest farming states, And now from next month, the issue of crop burning, pollution in Delhi, all those things are, it will start appearing this year also. So to avoid that to certain extent, the crop residue, that is wheat or primarily wheat. So that will be taken to process as ethanol in this refinery, Panipat refinery. So the target is twofold. One is by selling that farmers will have some additional income. So which will prompt them to sell it instead of burning, it will prompt them to sell it. Second thing, naturally the pollution reduction. So ethanol production from wheat residue, that crop residue is also a technology being developed by all refineries, especially all North Indian refineries. And then again, there is yet another technology, that is the off gases, OFF gases. That is another byproduct of the distillation process. That is, you can say methane, ethane, and all. So some of the gases escape also. So that again, they are trying to recapture, blend with this crop residue, so that a more richer mix is coming out as the end product. So that project is also going on. Maybe in another 1 year, 2 year, this kind of technologies will help us in achieving that 20% blending of ethanol.
Sir, one more question I have is so regarding marine diesel fuels, marine fuels.
Yeah.
So, sir, I had actually learned a subject called marine diesel engines a long time ago. So, in that, Europe and USA, they had actually emission norms for ships that were coming in to port. So, in India, is there anything like that? Is there any emission norms?
It is there. That conforming to that international standard, IOC was the first to launch. They launched this product. That name, unfortunately, I'm not getting it now. In January this year, they launched that product so that international carriers also can be supplied the fuel, which is as per the norms, as per the fuel specifications prescribed by international carriers. So it's already there, it's produced by Indian refineries and is in supply.
I think general public, we are not aware that that's one side, that the government is also focusing on emission control of from large ships also, not only transport, but
Correct. Very true. You pointed out correctly. But that it's already there. It's being supplied. It started because during January, we have that oil conservation activities. So during IOC in charge here, Kerala SLC was mentioning about that product, and Cochin also probably the supplies would have started. Cochin, unfortunately, the marine fuel supplies are less compared to, if you compare Colombo, what is happening at Colombo and what is the marine fuel sales at Kochi, you cannot compare. So we may be doing about 5% of what Colombo is doing.
Okay, sir.
Some more questions here. Hydrogen. Camera is using hydrogen cell because I have told initially some of the information will be carried from you to me. It's not that I am expert in everything. Then next comment, BS6 vehicle fuel consumption is more or less compared to what I am. We have lots of driver trainers. So some of these trainers are even called by Ashok Leland to impart training to other drivers. Okay, especially in Tamil Nadu side, we have many experts. So the feedback what I get is BS6 buses are more efficient than BS4. So that is the feedback I am getting. Again, the gear shifting for BS6 fuels will be faster, or in other words, the time to attain the highest gear, third to fourth to fifth to suppose sixth is there, time required is lesser, and then the engine electronics is improved in BS6. So lots of positive aspects. So efficiency is also on the higher side. That is the feedback from the field. Same EV using ultra capacitor for getting high acceleration and lithium ion battery for normal operation. This is this can you? I didn't get this. Same EV using can you just in the chat box?
Ashik AC, your question is not clear. If you are available, can you unmute and interact?
Or even it may be beneficial for the everybody's this thing, because what the point I think he's throwing some insight into ultra capacitors and ion batteries.
Yeah, I think so.
Maybe something unknown to me also.
Ashik AC.
BS6 vehicle I already explained, because from the field feedback is that BS6 buses are performing better than BS4 as regarding mileage.
Sir, one question.
Yeah, please.
Hello, sir.
Go ahead.
Is it suitable for high range purposes?
Yeah, no issue in that. All that hilly travels already taken care of.
So one more question.
Again, hydrogen as fuel, it's in R&D stage only. That's all I can say. So I cannot. I am unable to elaborate further because of my ignorance on this hydrogen fuel cells.
Is there any more questions? Okay, sir, thank you very much. So then I think we can move on to the final stage of our this thing. So I have been given the opportunity to propose the vote of thanks. So, sir, on behalf of Department of Automobile Engineering, SCMS School of Engineering and Technology, and SA India Collegiate Club of SCMS, I extend a very hearty thanks to Shri Suresh Kumar and all those present here. First of all, a big thank you to Shri Suresh Kumar, who shared his experience in the field of energy efficiency, and he has enlightened us on a lot of topics on how fuel efficiency can be maintained while driving, which is very important now. Something which we can contribute, even though we are doing research. If we are learning about new fuels, we can also contribute by this fuel efficient driving. And I also extend my thanks to our management and also to our principal, Dr. Provinsal CJ, for giving us the opportunity to conduct this webinar. I also place on record our sincere thanks to Dr. Anita G. Pillai, Dean Academics, for sharing the contact information of Mr. P. Shivanand of PCRA, who connected us with Shri Suresh Kumar for this webinar. I also thank Mr. Richu Zakaria of SEAM Kerala for his support in organizing this webinar. I also express my sincere gratitude to our student Gokul Krishna of S7 Auto, our arts and design specialist, for the poster and certificate which he has designed. I also thank Sujay K, Assistant Professor, for welcoming our esteemed speaker. Last but not the least, thank you participants for attending this webinar. I know you are all eagerly waiting for the feedback link. I will be sharing it now. Please fill the feedback link and you will get your certificates in the mail. So, Suresh Kumar sir, thank you very much once again for accepting our invitation on this holiday and talking to us. We have actually got a lot of information regarding alternate fuels and fuel policy in our country. Thank you very much, sir.
Thank you, and definitely we'll keep in touch. Not only these kind of webinars. Let us once the situation is